Hi, in this video we're going to be taking a small little time here to talk about the idea of a plausible or definitely true event. Okay, so in this class I've mentioned a couple times we're never going to prove anything is definitely true, and that's going to continue throughout the course. But what we're going to be doing is sometimes saying something is plausible or unlikely. And so we need to kind of discuss a little bit about plausible versus definitely true. All right. So if we create a null and alternative hypothesis and then we make a chance model off that null hypothesis, then we've got a couple of options here, right? We have that nice little picture like we had above of the yummies. If our statistic fits inside the picture, close to the middle, we call it usual and expected in the chance model. Okay, well, if that happens, that mindset was, okay, you know, my assumption was believable. I keep saying that. First 2 weeks, I kept saying that over and over again. My assumption's believable. How do we say that in our new terminology? Instead of saying, okay, my assumption's believable, we'd say the null hypothesis is plausible. I've gotten some data. I'm evaluating my data with my assumption, my null hypothesis assumption in my brain, and I'm saying, okay, it fits, so that's good. I did not prove that it's true. I just said, okay, it fits, right? With the limited data I have, it fits my model, all right? We do not say the null hypothesis is definitely true. Okay, so why? Give me an example of when you might get in some data and it would fit your model of the situation, but your model is not true. So let's say you go outside and you see that maybe you have a garden or plants outside and it's wet. Okay, so first thing you saw when you walked outside is your plant. Within this information, it is plausible that it rained recently. You see a plant. On the plant are some droplets of water. You say, okay, well, how did that happen? It probably rained. Did it definitely rain? You cannot alone say it has definitely rained at this point because there are technically other explanations. Now, the idea is your head is saying at this point that, okay, there's all these explanations possibly, but the one that is most likely is that it's rained. And that's why you're saying, okay, fine, it's probably rained because that's the most likely one. But you can't say it 100% rained because that's not enough information. There are still other options out there. For example, the neighbor dog doesn't like you and you don't like her. Your relationship is a back and forth of spiteful actions taken to enrage the other. As you bend over to check your plant, you see this face staring right back at you. And you slowly realize it did not rain today. There is another explanation. And you're looking right at her. So this is an example of it most likely did something, but there's always a chance, there's some probability that there was another explanation. And it's important to always keep that in mind. While 99 out of 100 times, you assuming it has rained from this information is not going to hurt you or any decision you make going forward, right? But 1 out of 100 times, it won't have rained. And you need to just be aware of that when you are making decisions. And that is a key point that we need to really be thinking about, that we are going to be able to soon put those numbers I just put on this. I just made up 99 out of 100 and 1 out of 100 in this make-believe scenario. But what we're going to be doing very soon is actually putting real probabilities on these events. So we're going to be able to say this crazy other explanation of this neighbor dog doing something to your plant, right? I can actually put a probability of that happening or something similar to that happening. I can put that in front of you. And then you'll get to say to me, once you have that number, well, there's a probability that it wasn't rain, and I understand that what this number is. Okay, I know that now. All right, I'm still going to make decision X or I'm going to make decision Y. And it's a balancing act. Is that probability high enough to make you change your decision? Or is it low enough for you to say, I'm just not going to worry about it? Maybe there's a 1 in 1,000 chance I'm wrong, but 1 in 1,000 is so small, who cares? That's actually a key component of this course we're going to dig into a little bit later. All right? So just remember, as we're going through these, it's always plausible, not definitely true. Okay? Plausible, not definitely true.